looks a lot better now. So, how are you guys feeling today? Good? Yeah? Did anyone break production today? No? Liars. Okay, so my name is Ricardo Magalhães. I'm a DevOps engineer here at xgeeks, and today we're going to talk a little bit about DevSecOps and how we can bulletproof your development workflow. And I thought about starting with a simple scenario. So we can meet the actors first. So this is Nicole. She's a full stack engineer. You can say hi. She's waving at you. Hi, Nicole. This is Paul. Paul is a security guy. He does security testing and whatnot. What? Come on. He looks good. And this guy is Ricardo, so he's a DevOps engineer. He does YAMLs all day. I have no clue, so we can skip this guy. And Nicole was tasked with a new feature, and she's pretty much working with a basic workflow. So locally, she's building, she's linting, running unit tests. Everything's OK. When she pushes her code to the remote repository and opens a pull request, the CI is triggered that I so masterfully have created. And once again, everything is guaranteed. So build, linting, run unit tests, everything once again is OK. So once she merges this code and she gets the positive reviews to do so, it's merged to this kind of pre-production environment and everything seems to be OK. She checks it, everything is OK. So there's some hope that she can deploy this code to production very soon. But since it's Friday, she's going to wait until she does so because I don't know if you know, but Friday is not a great day to make a deployment to production. But everything seems to be looking great and there's some green light at the end of the tunnel. So at this point, her work is done. So everything is looking great. She can rest, she can take a deep breath, and I'm going to do so as well because it's been a long day and you can do it with me if you want. So. And then you get one of these, and don't you guys just love it when it's like 5:50 in the afternoon on a Friday, and you get one of these emails full of findings, and you thought your job was done, and it's not. And then everybody starts to panic. Your boss, you panic. Your dog panics because you're panicking, so he's going to look at you. He's going to panic as well, so it's just a mess. And I'm sure at this point you can understand that this is a momentum killer, and there's some questions that arrive, and I'm sure you have a lot. I have too. So what chunks of code have been analyzed for how long did it take for these security scans to come in? Am I still deploying to production based on this result? So there are a lot of questions, but before we actually dive a little bit into this, I want to go a little back and to the genesis of the problem itself. And very quickly, and I'm not going to over-explain what DevOps is because all of you guys know what it is, but between development and operations, there was this communication gap where once the development process finishes with whether it's a bundle or a group of files, this was sent to the operations team, and then the operations team had to grab that, run that somewhere, and if something was wrong, then everything, of course, went back, and then it had to be finished. Development has to fix this. It takes time. Once again, it's a momentum killer, so DevOps really came to really solve this issue with all of those automations and whatnot. So, and I think, in my opinion, nowadays security, it's pretty much operates the same way. So it's working in a silo, which means that it's not part of the process itself, it's not streamlined, but it's a destination of the process. So once the DevOps process is done, the code maybe goes to some team that you maybe don't even know and have no connection with. You don't know who you can talk to. And what ends up happening is that since it's not part of the process, security is going to end up being sacrificed because it's basically an outlier in the process. And in here, this is what DevSecOps really comes to shine. And let's break it down a little bit. So DevSecOps adds part sec, so security to the word. And we can start with DevOps. So I don't really think there's a perfect way to describe what DevOps really is. Because if I ask 5 of you after the talk, how would you describe what DevOps is? I'm getting 5 different answers, and that's fine because I think we can all agree that none of us knows what DevOps really is because we don't. So let's just say that DevOps is the culture as well as all the processes and tools employed to deliver better software pieces and do it faster. Is that good? Yeah? Okay, so for DevSecOps, we want all of this, obviously deliver better software pieces and do it faster, but guaranteeing security right from the get-go. So looking into the future, security cannot be sacrificed anymore. And this means that it cannot be a destination of the whole process, but it needs to be part of the process itself, which means it needs to be streamlined. And by doing this, we make sure that resources are not wasted with some team that's going to get that code, analyze that code. Maybe we don't do anything with those results, so you're wasting resources, and it's just a mess. And I think at the end of the day, if you guarantee code quality, security, and fast delivery, quick time to market, obviously, your product is going to win. So the first concept that we're going to talk about today is the concept of shifting left, is the one that I'm going to talk more about today. And very simply put, shifting left is just the process of moving something earlier in the process. So when I say that I want to shift security left, what I really mean is I want to start testing as early as I can. And with this, there are a couple of advantages that come with it. So if we scan early on, obviously we're going to find securities early on in the process, which means that we're going to be able to fix them a lot faster, which means we're going to have fast delivery. Cost is going to be reduced because we're analyzing small chunks of code, which means it's much more easier to fix than actually waiting a month to analyze this month of code, basically. And it's going to be a lot easier. The cost is going to go down, and all of this builds up for improved efficiency. Then we need to know what to protect. And I think in here, the concept of protecting is, you can apply this to anything. So you want to protect your software, you want to protect your house. It's basically the same thing. You look into the parts of it, to the components, and you start seeing the vulnerabilities and where you need to protect. So how do you guys protect your house? You maybe build a fence around it so people don't walk in, right? You make sure that the walls are sturdy, that the doors have locks, maybe that the windows are strong as well. Maybe you set up some security cameras around the property. Maybe you have pit bulls and crocodiles. Or if you want something more aggressive, chihuahuas. You know, that kind of stuff. And with software, protecting software is basically the same thing. You look into what you have, into all of your components, and you start seeing, how can I protect those? So if I take this example, and I don't want to go very deep into it, so you have your code, your third-party libraries, and you package everything to a container that then you have a tool like Kubernetes orchestrating that for you. And then obviously you have a tool managing your infrastructure. So let's go one by one. And we can start with the third-party libraries, which is the outside body in your code. You don't really have control over this, or a lot of control over this. So all of those imports that you're putting in your code that are bringing functionality, they're also bringing vulnerabilities, which means you need to know exactly what's injecting into your code. And now I just gave the example of the house, protecting your house. Let's talk a little bit about decorating. Let's say we're decorating our living room, for example. And let's say you guys know that you don't necessarily need to use third-party libraries, but sometimes, for example, you can build a chair, you can build a table, but sometimes you're just walking through IKEA and you see that perfect couch. So you're going to buy it because it does exactly what you want. But you need to know exactly that the couch is good, that it's not full of termites. You need to check all of those things. And to check third-party libraries, we look into something which is the software composition analysis. And this type of scan does exactly that. Everything that you're putting in your code, importing it, you can scan with this type of scan. So this is what we want. Then we're looking at your own code, which is your ownership, which is the code that you copied from Stack Overflow, let's face it. But so you need to check this as well. And when we talk about this, we talk about the furniture that you were brave enough to build yourself, maybe a chair. And in here we have two types of scans. We have static application security testing. This type of scan is going to look into your code. It knows exactly what kind of vulnerabilities exist for certain languages. And what it does is it looks into your code and it tries to match it with a database of known vulnerabilities. And then it's going to alert you exactly where the vulnerabilities are. And taking that share example, so you took that DUI video at YouTube, You were brave enough to build your chair, but you need to check if it's sturdy and if it's not going to break if you invite your parents to dinner, right? Makes sense. Then, another way to check your code is with dynamic application security testing. And this one shifts a little more right than left, but I think it's worth it to mention it here because both of them really combine for a great code scanning. So dynamic application doesn't know about your code. It actually needs your application running. It finds runtime errors. And since it actually needs your application running, it's going to be more expensive to fix if you find something because obviously you're not scanning every time you open a pull request, for example. So in terms of code, we're talking about a bigger code base. Let's say you need to analyze and fix if you find something. And the way that we look into this is Dast tries to break your code. So if we say that SAST looks if the chair is sturdy, Dast is going to try to break the chair. Like for example, an hacker would try, right, to break your application. Between one or the other is not really, I don't think there's a definitive answer. It depends on your use case. If you want a quick win, so for example, if tomorrow you want something palpable, you can go with SAST because it's very easy to integrate. You can easily find an action on the marketplace that you can put on one of your workflows, and you can have quick feedback on it. But if you want really something more robust, you actually want to implement both of these, and you're going to get much better results. Then we packaged everything into a container. In the container, we have our chairs that we built, we have the sofa that we bought, but then the container is really the living room. And in here, we want to make sure that walls are not full of mold, there are no leaky pipes. And container scanning, there are a couple of things we need to be attentive of. So, and it really depends on how the container is built. So it starts with a base image. And that base image, let's say, it's an Nginx node base image. Those, you do not have a lot of control over them, but they bring vulnerabilities to your code. And the biggest chunk really comes from that. But apart from that, apart from the base image, you have your code being copied inside. You have network configurations. Let's say a known use case or a known problem running containers as root. That's a situation that can be exploited up to the point of someone taking access of the host machine where the container is running. So all of that needs to be checked. And container security analysis is the way that we can do this. Then we can talk about infrastructure as code. In infrastructure as code, we're really looking into the foundation of the house. The foundation, the structure. We want to make sure that it's sturdy, that a gust of wind is not going to tear it apart. And in here, you're launching all of those resources on AWS, Google Platform, Azure, whatever it is. Those resources, you're looking into, you're exposing applications online, so you're looking into open ports, overly exposed CIDR blocks, misconfigurations, services that maybe are outdated, and infrastructure scanning really looks into those. Then, Kubernetes Cloud Platform. We took our container and our services are being orchestrated with Kubernetes. And everything that we're launching, whether it's a secret, a deployment, stateful set, all of those we need to look exactly into best practices, known vulnerabilities. And here, this is what I want to check. So everything that we launch into Kubernetes is run against several APIs. So we can look into deprecated API versions. We can look into role-based access controls that are too permissive, sensitive data that is explicit on config maps, for example. And this is what we want to check with this kind of scan. And then, now that I'm done hammering you, don't laugh, come on, that's my grandma. It's not. Now that I'm done hammering you with all of those scans, I think one of the things that I think is important is to really make a bet on observability. And I know this looks a little bit out of focus in here in this talk or an outlier, but you should really make a bet on observability. You need to know at all times what's happening with your system. And within your system, you need to catch errors, live incidents, and observability is really what's going to guarantee you that. Talking about tools, Datadog is a great one, a very complete one. It's a paid one, so if you cannot get it, you cannot have it, maybe look into open source tool like Synos, for example. But really, making a bet on observability is really going to help you have a better control over what's running. Now, we've talked about all of those scans, and I think here is really where things start to really get a little bit dependent on your own use case, but I want to make something objective. So let's say we're working with a continuous integration flow and a continuous deployment one. So very simple. And going one by one, we can start with software composition analysis. This one is a great one for continuous integration because it's very easy to integrate. It executes quickly, and you can get quick feedback on it. But I understand that some people, maybe I think so, this looks into third-party libraries, and they say, okay, I haven't added any library in this commit, so maybe I don't want to check this. So you can start tweaking it to your own use case. Maybe you didn't have a dependency in your package JSON, and you don't want to run this on every continuous integration workflow. So schedule it. You can run it once a day, once a week. I don't mind running this on continuous integration because at the very least it's a reminder of what you have in your code. Then SAST. SAST for me is hands down the perfect fit for continuous integration. And just like software composition analysis, it's quick to integrate. It executes very quickly, and from that you get quick feedback, so it's perfect for CI. Then you have DAST, which is the one that I said is shifts more right than left, because you actually need something running to check it. So in here, you actually want your continuous deployment to run, have your application running somewhere, and then you can have a tool analyzing over that. And once again, here you can tweak it. Some people prefer to have it after you deploy your application. You run your tests immediately, but you can schedule it as well. It really depends on your preference. Then continuous image scanning. Perfect for continuous deployment, in my opinion. You build your image, and then you deploy it, so this one's really perfect for CD. Then, infrastructure as scanning. I think is also perfect for continuous integration, and in here you can have a couple of situations. So if you have your infrastructure files in their own repository, you can maybe scan every time you open a pull request, so perfect for CI. Or even if you have them together with another repository, maybe you have them in a folder, you can scan them. You can trigger one of these scans every time that folder is updated. And finally, with Kubernetes scanning, there are a couple ways you can do it. Usually, tools allow you to run a scan based on what is running on the cluster already. But if you don't want to deploy and then run a scan over what's deployed, and you want to maybe choose to deploy or not based on the result of this scan, you can use it on continuous integration by scanning manifest files. So in here is really up to your preference. Then tools. I'm not going to talk a lot about tools. I'm not going to suggest tools. But in here, I think you really need to make a fundamental choice based on a couple of things. Can you pay for a certain tool? If you're going to pay for certain tools, maybe you're going to get, and you're going to get better results. But if you have to go with open source, you really need to know and start comparing this tool with that one. This one gives me more. I think this one doesn't really find exactly what I want. So in here, I think it's important to allocate time to execute proof of concepts. And with all of this, you can make a fundamental choice. And then challenges, because they're going to come with everything, and we need to be prepared to face them, or at least how we can deal with them and know that they exist. And I think with DevSecOps, it really comes down to the maturity of the project. So as you can imagine, implementing a culture and processes is going to be a lot easier if you're starting a new project, because people are not expected, or people are not used to working a certain way, so they're more willing to start using a certain workflow or using a certain tool, rather than working on a project for 1 year, 2 years, they're used to tools, they're used to workflows. They're going to be a lot more hard to convince, basically. So the first one, and I guess this one comes in form of an advice, which is do not integrate all of these scans at once, and maybe if it's someone that's not so familiar with all of these scans, it can be like a kid in the candy shop, so I'm going to integrate this one and that one, but this comes with a learning curve, all of these. And we can start with a new project, for example. In here, a lot of our problems are actually fixed for you, because if you're starting a new project, you're probably not having a Kubernetes deployment, you're not deploying things using Kubernetes, for example. You probably don't have infrastructure as code. Maybe you don't even have a Docker file, so all of those scans, you don't need to worry about them initially. So you can start slowly implementing software composition analysis, then go for SAST. Once you have Docker file, you can start checking your container, and so on and so forth. But with a more mature project, you probably have all of this in place, but the suggestion is exactly the same. You take it from the beginning. Software composition analysis, then you go with SAST, container analysis, IAC analysis, and so forth. Then, building the culture, and this one is probably the most important one, because it's going to be a very hard one, I guess. And in here, you need to have everyone on board. So you need to be on board, development team needs to be on board, product needs to be on board, everyone needs to be rowing in the same direction like these guys, even though they're not going anywhere. But everyone needs to understand exactly what they're gaining when they're implementing DevSecOps. And I think even more importantly than understanding the advantages is understanding what they're going to lose or what are the risks of not employing this kind of culture and these kind of processes. And just like I said, building the culture is going to be a lot easier if you're starting a new project. People are not used to working in a certain way, as opposed to someone who's working on a project for a long time, is used to certain processes, certain dynamics. So if you try to implement something new, it's going to be a lot harder. So in here, it's important to bring everything together, and it takes time, commitment, takes your sanity as well, but I think it can be done, and I think it's very worthwhile in the end. And in here, it doesn't necessarily need to be big things. I know this is a big concept, building culture of a team or even a company, but it can be small things. So let's say one of your developers has a pull request open and one of the scans is failing. You know you're going to get that cheeky DM saying, can you maybe bypass the checks, merge my pull request? This is your opportunity to build the culture, and you have to say no. And you have to say it in caps because they need to know you're screaming. So then, dealing with security debt. I think the guaranteed thing here is we're always going to have security debt. We need to know how to deal with them. And in here I created two main concepts, which is, the first one is creating baseline. And a baseline is just a starting point. Is when you perform a scan, you take exactly what you have. You have 2 critical vulnerabilities, you have 5 highs, 10 mediums, and you create a baseline based on this. Maybe the criticals you need to fix right away. It really depends on compliance and who you're working with, but creating a baseline is just defining these numbers. Is defining how many highs can I have at this specific moment, how many mediums I can have, all of this to not basically break your workflow, because if you start taking all of your team members and saying we need to fix all of this, you're not getting new features, you're not advancing product. You need to focus basically or solely into fixing all of these vulnerabilities. And creating baselines is just a way you have to not halt your workflow, to not basically stop creating new features, but at the same time you still make a commitment with security. So for example, if you say, I have 5 high vulnerabilities right now, if you find a new one after that, so if you find 6, that's the one that you need to start acting on when you create baselines. But just because you have baselines, it doesn't really mean all of those high vulnerabilities and medium that are part of your baseline that are going to be forgotten. You still need to deal with them. You're just not going to deal with them immediately because otherwise you're going to stop working. And in here, I think it's important to have a pretty well-defined process in place. And this means that you're making a commitment within the team saying, every sprint I need to fix 3 high vulnerabilities, I need to fix 5 mediums, and in here is really the process that you build. Another concept is when to break the build, and when to break the build is really when you have all your workflows in place and all your processes, you really need to set a place where, okay, this is where I'm enforcing security within my project. So let's say, for example, we have a SaaS scanning. When am I going to break the SaaS scan? And we just talk about baselines, and I think baselines is a great example of when to break your build. Let's take the same example. You have 5 high vulnerabilities, you have 10 mediums. This is where you break the build, basically. So if you find the sixth high vulnerability, the build is going to break because you're breaking your baseline. So this is where it needs to stop, and this is how you can ensure quality and security in your workflow. And then, I think one of the final concepts is embrace breaking the build. And maybe a little known fact is just because a pipeline failed doesn't really mean it's broken. It doesn't need to be fixed. Maybe a SaaS scan failed. Maybe a container image scan failed. It doesn't need to be fixed per se for example, by a DevOps. But embrace breaking the build, I think, is one of the most important parts, because in here you can really, really enforce security within your process. And it does mean that more work is coming because you still need to fix that scan. You still need to fix that vulnerability that you just found. But this is really where you enforce security. And I think we all like a green pipeline, or when everything is successful. But at the same time, I think just as important as a successful pipeline is one that breaks when it should. So in here, I think it's really important to embrace this concept. And I think it's all worth the while when maybe you have to spend a lot of time fixing things and it's 2 a.m. and you have drunk 12 coffees in the last half an hour, but when you get that green, it's all worth the while. There's always going to be those cases where the pipeline is in red and someone says, oh, the pipeline is broken. And guys, I have the perfect way to respond to those people. Did you try rerunning it? I'm kidding, by the way. Seriously, though, did you? Come on. Okay. But with this concept, I want to do a little game with you guys, and I've done this in Visio a couple of weeks back, but I really need to know your opinion because these kinds of things keep me up at night, which is how many times do you guys rerun your pipelines? I really need to know. I got a number in Visio, but I want to know your opinion. So can I get 3 numbers, for example? How many times do you guys think, or how many times do you think we can run a pipeline without the situation just being sad? Can I get some numbers? 4? 2? Can I get one more? 3? Okay. 2, 3, 4, okay. Can we vote? Let's say 2 times. How many of you? Okay. Okay. 3? Okay. And 4. Okay, I think 3 won, and I think that's the number that I got in Visio. So, and I'm not sure that if you guys have run your pipeline for a 4th time these last couple of days, but if you did and you were overcome with an immense feeling of sadness, it's because of us. It's because of what we did in Visio. So, and also now you guys are part of this with us as well. Every time you run a pipeline a 4th time, you'll be overcome with an immense feeling of sadness. So you guys should be proud about that. And just to wrap things up, the whole problem is that security is being siloed from everything that was the DevOps processes. And in here, security was acting as a destination of the process and was not streamlined. And this is exactly what we can fix. This security has to be streamlined in order to not be the destination and be part of the process itself. This means that once we have this streamlined, we need to understand the vulnerable spots in our code. We need to know how to protect them. And in here, we need to know what kinds of scans we have at our disposal. Once we know that, we need to bring everything together. We have our scans, we have our workflows. How can we integrate all of these scans into our workflows? And then, of course, challenges. What are the challenges? How can I deal with them? We need to be prepared. And thank you guys for your attention. If you guys like tech stuff and get videos, please follow me on my socials. And thank you guys. If you have any questions.
Thank you, Ricardo. So, any questions for Ricardo? Any doubts that may arise? No one? Yeah. Please feel free.
Yeah. Hey, Ricardo. I'm thinking, for example, I recently joined to the company that they are very in the beginning processes of the DevSecOps, and what should I started at this company? For example, should I started to scan the Docker images? Should I started to scan the code that they write? Should I started to scan the infrastructure that is on the cloud, but the infrastructure was built manually, not as infra as a code? So how should be my approach to starting working with that?
Yeah. So personally, I think the approach I like the most is to start with the order that I just mentioned, which is software composition analysis, third-party libraries. You don't have a lot of control over them. Then you can go for static application scan. Then you go for container, infrastructure, and then Kubernetes. Of course, this can change because maybe you're dealing with a client that is imposing you to do a certain way. Maybe they need infrastructure to be scanned, and that's it. That's what they need to enforce, and you need to start with that. But other than that, I would follow that specific order. So software composition analysis, SAST, container, infrastructure, and then Kubernetes.
Yeah. Sounds good.
Thank you. Anyone else have any questions for Ricardo? No? Everything is okay?
Yeah.
So, if so, no, one over there. Don't be shy.
Thank you for the presentation, and I want to ask, like, if you have to take some like Scrum time for this DevSecOps because it fails, and like you have to deploy some application, and the application deployment is just getting more time and more time because of the security issues. Like how you handle this with the development team or other teams?
Yeah, that part is where you need to define. Basically, I don't want necessarily say cut your losses, but at this point you can take the concept of baselines. So you cannot stop deploying. Obviously, nowadays with the time to market that you need to have, you cannot stop deploying. At that point, you need to decide what is my baseline. How much am I going to allow to enter my code and then ship to production? So can I allow these 5 vulnerabilities? Are those going to stop me from deploying? And in here, you can have more liberty to define yourself or within your team. You can have a client imposing that. Maybe the client isn't necessarily going to look at that first. So he's saying, on Monday, I need to deploy, and that's it. But in there is really where you define the process itself. Where do I draw the line? Where, let's say that, for example, criticals, you will not allow criticals in your code, but you will allow 5 high vulnerabilities. That's where you define your baselines. And apart from that, anything above that baseline is exactly where you break the build, where you stop your code from going into production. But it's important to have that process really cemented. The team needs to know what the process is. The product needs to know what the process is. And it's just about cutting your losses. Is how much will I allow my code to have before I can deploy this? So you're always, it's like you're trying to see basically balancing the good and the bad of having your code to production, and what is the cost of having this code in production with 5 high vulnerabilities. How much is the code exposed? How much are they going to take advantage of it? So you need to, I think the most important part in here is have that process very well cemented within the team and product.
Of course. So what is the hardest part and why is it changing company culture?
Because, and I've dealt with this a large number of times, I think too many for me to count, is I think it's people. People used to certain processes, people working together for a long time, people working in a certain way for a long time, and then you come in with a new concept that maybe they don't understand very well, and then they tell us, well, this is working so well, why do this now? And how do you shift that change? Is about building culture, right? It's going to be hard, and especially if you enter mid-project, right? It really depends on the maturity of the project. Not only project, it really depends. It might be focused, like you said, on company environment, company culture. Is just mindset. Is if this is working for such a long time, why am I implementing this new concept? That just maybe it appeared 2 years ago. If everything is okay, why do I need to shift what I'm doing to implement this new concept? I think it's a little bit that is people and how people think, how people are used to work. I think that's the biggest issue around this.
How do you get the buy-in to make changes?
How do you shift their mind?
Yeah.
By telling them exactly what they're going to lose by not implementing this. Basically, if you don't want to be responsible for the next big breach in your application, so they need to understand if they mess up, it's going to cost a lot to the company. It can have its costs to, for example, for you. They need to understand that. They don't want to be the cause of that. And if they don't understand that, they're always going to stay in on that mindset. So if this is working for such a long time, why am I implementing this? Because this is going to happen. It's going to suck. So that's exactly how you try. Or I think that's the best way you can shift someone's mindset.
Any more questions for Ricardo? So, no, this time, yeah, I think is it.
Yeah.
So, another round of applause for Ricardo. I think he deserves.
Thank you, guys.